Hey everybody, this is Mr. Munson. We're at Unit 2, Circles. We're in concept number 5, and we're looking at arc lengths and sector area. And so if you take a look at this nice piece of pizza, one of my favorite foods, we know that a piece of pizza is just part of a big, huge circle, right? And so what we're going to be looking at is what is the physical length of this crust? What's the physical length of it? Now we've talked about the measure of it, and that measures the unit of measure that we use there is degrees. So that might be, let's say, a 45 degree of arc there. But what we want to do is be looking at it and seeing if it's like 13 inches long or not. Okay, and we also want to know what's the area of the pizza, the entire area. You know, how many squares does it take to cover this thing? So when we talk about area in squares and stuff like that, we're looking at the final area of something like that. So let's see if we can get started and find out how to do this work. So if you take a look at this circle has, we can certainly talk about circumference. You've had that in the past, and that's the formula for it. And this circle allows us to work with the radius of a circle, and this represents the circumference of the circle. Okay. Now, if we know one, then we can find the other. So if I told you what the radius is, you'd plug it into the right side and find out what the circumference is just by calculating. If I gave you the circumference amount, this amount that's over here, if I gave you that amount, then you'd plug it in there for C and then have to solve for that R there. Okay. As we go through here, I want you to use pi as 3.14 or the button on your calculator. Okay, that'll just be a standard thing from now until the end of the year. All right, let's take a look at where we're going to use this idea. Okay, so here we are with a circle and 2 points on the circle, so we could talk about arc AB. Now, up until this point, we would be asking, what is the measure of arc AB? That might have been a question given to you, right? What's the measure of arc AB? And so we used central angles, inscribed angles, and all those things. And when we answered that question, we were in degrees, right? So many degrees. The angle cut in it had some kind of direct relationship, like the central angle, it was 1-to-1, or it might have been a half relationship like the inscribed angle has. But this time we're going to be looking at a completely different concept. It's called the length of AB. So you want to make a mental note, if not a written note, how the length of AB is a completely different question than when I ask you what is the measure of AB. Okay, they sound very much alike. The measure is in degrees, and the length is in things like inches, centimeters, and stuff like that. So even though I color across this arc like we have done at the measure, I can color across and say what's the length of AB. So now we're talking about measuring it with a ruler, but it's curved, so that might be somewhat difficult. So let's come up with a formula and see if you can follow along with me. So here's the formula that I want you to remember. It's a left side fraction and a right side fraction. The left side fraction is the measure of the arc, whatever it is in degrees, out of 360, is equal to the length of the arc out of the entire circumference. Okay, so the bottom numbers, the 360 and the 2 pi r, represent the total amounts of the concepts we're dealing with, okay? So on the left side it says 360 because the entire amount of arc measurement is 360 degrees. On the other side, on the right-hand side, the total amount of length around a circle is known as circumference, and that's 2 pi r. So the bottoms are the total amounts available to us for these concepts we're dealing with. The top amounts are the partial amounts. So like the measure of arc AB in this particular drawing would be measured in degrees, and it would be some amount of that 360, part of the whole, okay? And then the length of the arc, the actual physical length of the arc, is just something smaller than the entire circumference, some fractional amount. All right, let's look at a problem. Okay, here we are in an example. I'm given a radius of 3, and I'm looking at a 36-degree angle and a 54-degree angle. And I'm not sure what the angle is that creates that arc for AB, but we'll see if we can figure that out. But I can see that they're asking for the length of AB. Now, since they're asking me for the length of an arc, I'm going to pull in the equation that I know that has a component about the length of an arc. Okay, so what I'm going to do is try to cover up all the other unknowns, like I need to figure out what the measure of the arc is. I need to find out what the radius is. Everything else are numbers. 360 is a number, 2 is a number, pi is a number. And if I figure out what the measure of the arc is and the radius, then I can simply solve for the length of the arc. So let's continue over on the right hand side and start filling in the information. Now the length of the, or I'm sorry, the radius is real easy to see. I can see it's a 3. All the radii coming out from the center in any direction are always 3. So I know the radius is 3. Finding the measure of the arc, I can do that one as well. Finding the measure of the arc is just like finding the angle that cuts it, okay? So I have this angle over on the left-hand side. I drew an arrow. That angle right there goes out and cuts the arc that we're eventually trying to find the measure for. So if I can find that central angle there, I can find the measure of the arc. Well, that's not so hard either. I'll just call this an x, and I know that 36 plus x plus 54 has to equal 180 degrees, okay? So let me just use that to calculate, and I'll just solve for that x. Go ahead and put me on pause if you want. I'm going to actually pull out a calculator and do the work here, but put me on pause, and then you can see if you can figure it out on your own. All right, very good. X is equal to 90 degrees. It kind of looks like a 90, but I never trust my eyes. But since that angle is 90 degrees, then the measure of the arc is 90 degrees. Okay? So I know the measure of the arc is 90 degrees. Okay, so that's another one of the pieces I need. I need to know the measure of the arc that's being cut. So I think I have everything. So what I'm going to do is I'm going to go ahead and set up the equation, put the information into it, and then do some calculation. All right, so I took the arc measure out, threw in my 90 that I found. I replaced length of arc to arc length. It doesn't matter. I just put an A and an L there with an arc above it. And what I'll do is I'll simply solve this equation for that AL and find out what the arc length is. Okay? And again, I'm going to encourage you, if you can, put me on pause and see if you can do that on your own. If that's too scary, watch it unfold, put it on pause, and write it into your notes. So this is what we call a proportion, so it's a matter of cross-multiplying. Now before I do that, I'm going to clean this up and call it 6 pi. That'll make it easier. 2 times 3 times pi. Cross multiply. Notice I did not multiply times pi. Now some of you, no matter what I say, you're not going to do this, but I need you to do it. So for those people who can listen to the directions and follow me, I don't want you doing 3.14 on your calculator yet. I want you to leave it in terms of pi. Just carry it like it's a character. It's not an unknown. It's not like an x or a y, but kind of treat it as something that kind of holds together that way. As soon as you multiply times 3.14 or by the pi button on your calculator, this thing's going to go crazy decimal, and I don't want that, okay? So I have 540 pi equals 360 arc length. Now my next step is going to be divide. And so then I end up with this 540 pi divided by 360, okay? So now I'm going to enter that in my calculator. I'm going to go ahead and either use 3.14 or pi. I'm going to use parentheses to make sure that I take the entire top part and divide it by 360. Go ahead and do that on your calculator, see if you get the same number as I do. All right, so I didn't do any rounding. I just simply used the pi key on my calculator, and I got around 4.7, okay? So now the question I have for you is, that 4.7, is it in inches or degrees or whatever, okay? So if we look back at the radius of my original problem over to the left, let's say it said inches. Then this is an arc length. It's not an arc measure. Arc measures are in degrees. This is an arc length, so that would be in inches, okay? 4.7 inches. That's how you find the length of an arc. So let's have you use this model to do one on your own. All right, there we have it. We have a try it problem. So go ahead and put it on pause, get the information there, and then try to find the length of AB. So essentially I'm looking for what's the length of this arc. Now just like the other one, I'm going to have to go find the measure of that angle to know what the measure of the arc is. Bring the original equation in. Don't put any numbers in it. Bring the original equation in, rewrite it, then put the numbers in that need to go into it, then you're on your way. Go ahead and put me on pause and then come back and check your work. All right, welcome back. So I had to go find the arc measure, which is what goes on top of above that 360. And so I found that to be 126. It's a linear pair. So I just called it K and wrote an equation to solve for it, okay? Now, some of you might just do that on a calculator, but I know sometimes these problems get a little bit harder, so I always like to write an equation so I can manage it. So the radius is 4, and so we just plug the information in. So this time I just chose to put the 360 times arc length over on the left. And that way when I solve for arc length, it'll be on the left. Notice that 1008 pi is, again, I didn't multiply by the pi. If you did that, you need to write yourself a note and say, Mr. Munson told me not to do that. Okay, we do that at the very end so it doesn't turn into a crazy decimal. We just kind of hold it as a place value and we just kind of work it like it's an X, and then we but it's not. It's not an unknown. It's definitely a number. So 1008 is the 126 times 8, and then I just write times pi afterwards. Okay, next step, division. And there we have it. It's 8.8 units. Okay, and so I did the pi button on my calculator. I made sure I put parentheses around that top thing when I entered it in my calculator, so I made sure that I was dividing the entire thing by 360. Okay. So I just want to talk briefly about this kind of problem that we have here. Here we're given the arc length, 12 inches. You can tell it's not in degrees, so that's the arc length. I'm given the angle, the central angle, which is 45 degrees, which means that the arc measure is 45 degrees as well. What I'm missing is the radius, and that's what they're asking me to go find. What's the radius of the circle? Okay. Okay, so this formula actually can be used for that, right? To find the radius. I know what the arc length is, I mean the arc measure. Actually know what the arc length is. Now I'm just looking to find the radius. So that's going to be my unknown in this equation. Now let's just set this equation up. We won't worry about solving it. We just want to set it up so that you have this basic idea. Okay, so there's that kind of equation, and you can see that everything's been coming up with numbers. The only unknown is r, so I just simply cross multiply and solve for that r, just like we have been for the arc length. Okay, very easy. So I could actually use this formula to find the arc measure, the degrees one. As long as I know what the arc length is and the radius, then I could actually find what the degrees is. Okay, so in this problem, we want to know what the sector area is. So when we cut out like a piece of pizza like that, that's called a sector, or part of a circle, okay? And the area is the amount of squares it takes to cover this thing. We've found areas of rectangles in previous classes, you know, in previous years and things like that. The area of triangles and all this stuff. So we certainly know how to find the area of a circle. But that shaded part is not the entire circle, is it? It's actually a relationship between the arc length, I mean the arc measure, and the entire area. Okay, so let's write up a formula for this one. It's very similar to the arc length. All right, so there's our formula. We basically have the left-hand side of the previous equation. It's a measure of the arc over 360. And then on the other side, we have the relationship of the sector area, that piece of the pie, over the entire circle's area. So here's a question that we could pose, right? So I have an angle that's 92 and a radius that's 5, and it says, what is the sector area of the shaded region? All right, let's take a look to see if we can figure this one out. All right, let me slide that over to the left. And so let's write our equation with nothing in it. All right, and then let's take that and put our information into it. Now, one of the problems that we have with this problem is that the angle right here is what we really need to know about the arc measure of the arc that we're talking about. Okay, it's not just any arc measure, it's the one that is applying to the sector that we're looking at. Okay, so that's not too hard of a find. All right, and so I can find, let's just call that missing angle M for Mr. Munson, and find out what it is by, you know, the two angles, the 92 and M, have to add up to be a straight line. So that's the measure is equal to 88. And now we know the radius is 5. So we plug in the information. I'm certainly going to take care of that and turn that into 25 pi. And once again, we're just kind of working this by cross multiplying, okay? So I get, you know, 360 times that SA, and then 2200, which is the 88 times 25 times pi. So my next step is divide, and I'll go ahead and divide that out. Put parentheses around the top part in your calculator so you can get the whole thing. And I get 19.2, and since we're talking area, our units are always squared, so it's 19.2 inches squared. All right, draw your big black line write the word summary, take a few minutes, just summarize. We have two basic concepts. Maybe reiterate what your formulas are for this. Put them into your formula sheet, the blue sheet that I've given you. If you need to get that up to date, see me in class and I can give you some formulas that you might be missing. Okay? That means it's time for our do it problems. All right, well, there you have it. Let me zoom in so that you can have a better look and eat lots of pizza. There you have it. See you next time.